Welcome back to the hyperbolic beanie chamber. As you can see, my head has been growing rapidly. I'm going to see a doctor about it. And yeah, we're back once again. The hyperbolic suffering chamber is going strong. The levels by which we are suffering are multiplying by exponential values. So those time complexity masters out there will be able to tell that this is the growth factor here is large. So yeah, I mean, we have some comments as per usual. We have Brandon LSC who says, what do you currently do for work? Currently, I type professionally for a medium-sized company. And yeah, I do some back-end stuff there and kind of touch a few different pots, but hoping to learn quickly and make larger contributions. Not a FANG company though, but we do have a couple of people in the Discord who are massive, who are huge. We have Elon is in the Discord. We have many of the top tech executives in the Discord, as well as many of their employees. Many of the FANG employees are also in the Discord, so you're going to want to join for that. And yeah, I'd be curious to know how about you? So that would be interesting. Yeah, I'd be curious to see. I know a couple of people who talk in the Discord are students. I know one person in the Discord today said they were from Meta, so that is pretty epic. So we have another comment. I have just learned about arrays and arrays, ADT, and strings. Should I start practicing on LeetCode tasks with it and keep learning other things, or just keep learning other fundamentals, then start practicing? Jump in, bro. You got this. In a weird way, so I think so this could be difficult. It could be difficult if you don't know a ton about programming to jump into LeetCode. But it truly, the intersection of knowledge, like rote and supplemental learning with application, is like the gold standard. So you could jump into LeetCode, but you definitely would want to stick to like a curated list of specifically easy problems. And even some easy problems are absolutely ridiculous. So I think there's a couple of good problems in there. Like if you could just find some problems that just have to do with strings and arrays, it would be very difficult to start, but it would really bolster, I feel like it would really bolster one's understanding, because you kind of have to make sense of all these things you learn and kind of put them into place. And I think that act kind of cements it into the brain. But yeah, it's tough to know because also the easiness difficulty can be kind of spotty. We're working on an easy problem right now, but we just got word from Thomas that it's actually closer to a medium. So there's kind of a lot there. So it can be hard to know. But if you can find like a nice curated list of like the easy problems, I feel like it's like a really like nice cheat code in terms of like, there's a lot of suffering. And I think Thomas told a story about this the other day that I think he did a boot camp or it was university. I don't remember, but he pretty much told a story about pretty much being thrown into a pool, metaphorically, a programming pool. And while it was mostly one of the difficult things he had done, when you come out, the reward can be very, very, rewarding. So it's kind of like being thrown into the pool. You could spend a long time learning how to swim, but also someone throws you into the pool, maybe you end up learning how to swim in 1/100th of the time, because you have to survive. You can't quite recreate that in real life, but you sort of can by putting, pressure on yourself, maybe taking a boot camp, maybe there's risks and so on. But there's also a great risk of danger there. So you can get thrown into the pool, you might die. And maybe for some people who have like done boot camps or tried university or learning coding, maybe there's the loss of time investment, maybe loss of money, maybe loss of other opportunities. So it can be difficult to know. But if you could find a curated list, it depends. If you could find a nice curated list and supplement it with, some learning, like, something like elements of programming interviews or algorithm design manual. I mean, these are things that are pretty crazy to start with, but I mean, there are crazier stories on the internet. A lot of the people who seem to pretty much kill this stuff, are completely untraditional like routes, like, you know, they have some interest, but they're mostly driven by, you know, some will to like pretty much get where they want to be. So they kind of do these things anyway. Not saying that everyone has to do these things, but I don't, it really depends. Some people could just jump into LeetCode at this point. Some people might not. At the end of the day, I think maybe what's most important is keeping that flame going. So if jumping into LeetCode and not having a quick success could derail you, or, you know, demotivate you, or pretty much threaten the grind, then it might not be a good idea because you're still early. But I feel like as long as you keep practicing, you'll go where you need to go. So if it has a potential of derailing the grind, I wouldn't go for it. But if you're feeling like you want a challenge and this is something that keeps you programming, I would say go for it. But as always, there are people who are better suited to answer this question, especially in the Hyperbolic Coding Chamber Discord. So you're going to want to join specifically for those advices from these legendary programmers. And speaking of advice, I need advice on how to do LeetCode. So we finished a problem recently called min-cost climbing stairs. It was a legendary problem. I'll never forget it. We also failed the contest, and now we're stuck on a crazy problem called remove palindromic subsequences. And yeah, I'm not really certain what day it is anymore, or who I am, or how long I've been doing this, but the grind continues nonetheless. You know, I hope for a future, it would be, there are 560, I think, easy problems. And I think we tend to go, all things considered, at a rate of approximately 2 easies a day. So, assuming a linear pace, by the end of the year, we could have finished all easies on LeetCode. That would be pretty epic to have done. So, that would be pretty cool. Now, assuming that somehow our brain, our collective hive mind in the Discord, is able to exponentially get faster after each problem done, maybe it takes less time. So maybe we go from 1.8, our average goes from 1.8 1 week, then 1.9, then 2.2, then 3.2, 4.2. You know, maybe it takes less time, but even then, finishing all the easies by the end of the year, not the end of the year, but 250 days from now, we'll see if it happens. We shall see. That being said, you know what we won't see is me not doing an hour today. So we're going to do an hour today of LeetCode, Necessary Evil. Hopefully we can make progress on this problem. I started it yesterday, I think. We've been thinking about this problem for a lot, maybe 30 minutes so far. I'm going to put in another hour of brain thinking on it, and then we'll see what happens. But I'm not holding my breath. I'm not holding my breath, so we shall see. I'm going to put 1 more hour of brain power into it, and maybe things will change. Maybe they won't. But another hour, maybe it's a necessary evil just to search the whole maze of potential solutions. That way I'll know when I've added a new corridor, because there's a new technique we can add. But I surmise we won't make much progress today, and it'll just be us clearing the maze, or the palace, or traversing the palace. So who knows? And yeah, we're just gonna jump into it. So I'm gonna start the timer and jump into it. So the timer's gone. 135 are recording. Do I have enough disk space? Okay, we have enough disk space. We have a lot of disk space. So let's just jump into it. We're given a string S consisting only of letters A and B. In a single step, you can remove 1 palindromic subsequence from S. Return the minimum number of steps to make the given string empty. So we have a string, A's and B's only. In a single step, you can remove 1 palindromic subsequence from S. Return the minimum number of steps to make the given string empty. A string is a subsequence of a given string if it is generated by deleting some characters of a given string without changing its order. Right. Note that a subsequence does not necessarily need to be contiguous. So it doesn't have to be contiguous or non-contiguous. It could even be both. A string is called palindrome if yeah, and this is just a string is a palindrome if it's the same forwards as it is backwards. So here we have a baba, right? And the whole thing is palindromic, so you can just remove it in one sweep. Right? But we have A, B, B here, and on each round we can remove one palindromic subsequence. The only way to do this is two, right? We can remove A, because A forwards and backwards is a palindrome. Then we can remove BB, which is also a palindrome. But you can't do this in one, right? There's just no way to do it. You could also do it in three. So my tendons hurt. We have BA. Oh yeah, I just realized I forgot I was gonna fix something. People can't see my mouse, so give me 1 second. Okay, there's actually no way to show the mouse except if I use this desktop capture, which I'm gonna be honest is not the wave. But it's a little bit frustrating that you can't see the mouse. Anyway, it's kind of hard to see what I'm talking about. But I'll just highlight. So yeah, so that's what we're looking at. S, right? So there's only two ways to do this, right? A or BB. Then we have BAB, right? Which is not very palindromic, but you can remove one B and then remove it in one foul swoop. It just so happens to be that the B that we remove allows us to remove a palindromic subarray, not a subsequence. The length of S is up to 1000. And it's either A or B. Now, I guess another thing we never considered, why did they let us use, why is it only A and B? So why is it only A and B? What would be the difference? What would be different if, for example, you could have the subset of characters A to Z lowercase? Why does it have to be only lowercase a and lowercase b? What could be making the difference here? There must be a shortcut or maybe an optimization that is allowed. Nah, that we probably shouldn't think that way. Because now we're trying to figure out why the LeetCode people designed the question this way, which is probably not important. What is important is the salience of there only being two potential keys. So maybe, what sort of problems does this eliminate if there's only two potential keys? If we had if we had A to Z lowercase, if we had A to Z lowercase, what does that change? If we had A to Z, what does that do? It would be very difficult. But since we have A and B, the subsequences are much more simple. I can't really think too far about this one right now, but I feel like this is important. We have a few different ones we looked at. We talked about shortest path, which still seems plausible. Brute force. The reason shortest path seems plausible is because we're being asked to minimize something. We want to know the minimum number of steps to make the given string empty. And we could pretty much derive a step as a path, or we could derive a step as a vertex in a graph and simply do a shortest path to the vertex, the shortest path to the vertex that has pretty much the shortest path to the vertex that has an empty string. We said brute force, but it'd be unclear how we would brute force it. We also have hash map. And this is not really a method, but maybe we're looking more structurally at the string. Even if we put this into a hash map, there'd only be 2 keys. It's too bright in here. Even if we put this into a hash map, there'd only be 2 keys, A and B. The information we get from that, at minimum, wait a second. Wait a second. I think we might have, wait a second. Wait a second. At best, wait a second. Since there's only A's and B's, at best there's only ever 4 options, I think. The answer is always I think the answer is always greater than or equal to 1, or greater than equal to 4, or less than or equal to 4. And that's because there's only A and B. Wait, why is my screen so small? There's only A and B here. It's only A and B here. Which means that given any arbitrary string, we could take out a few different versions here. If we had AAAB, right, the answer here, the minimum number of steps to remove it, if we can remove any palindromic subsequence, would be 2, because you can do BB and AA. So that would give us 2. You only get 1 when the string that is given to us is actually palindromic. And then maybe you could get 3. No, it's not even, I don't even think it's possible to get 3. Even if we mixed in B and A and B in here, we could always look at the subsequences of B, 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 and A, and always get just A or B. Because if it's an odd number of B's, it's the same forwards as it is backwards. And if it's an even number of B's, it's the same forwards as it is backwards. So the answer is either 1 or 2, I think. So do we just have to check if it's a palindrome? And if it's not, we can just return true. Let's try that. So down here we'll write palindrome function. You start at left equals 0, then we go to right equals s dot length minus 1. It is called s. I'm going to do while left is less than right. We're going to check, right, if s sub left does not equal s sub right, then we're just going to return 2. The answer is always 2. Otherwise, we'll keep checking. We'll do left plus equals 1, right minus equal 1. Maybe this is too simple. Does it work for these? This is a palindrome, so we'd return 1. This is not, so we'd return 2. This is not, so we'd return 2. Oh my God. No way. No way. No way. Is this the power? Is this the power of... Wait, my thing isn't updating. My timer isn't updating. There we go. Is this the power of low expectations? No way. No way. I can't believe we got that one. No way. That is crazy. No way. I think we might actually be evolving. It only took 135 days. We were actually evolving. I just can't believe it. Alright, I'm going to put a crazy clickbait in today's video. That was crazy. This would just be linear time. So that was pretty cool. That is crazy to me. Is this a dynamic programming problem? Maximum units on a truck. Do reverse words in the string 3. Largest perimeter and count binary substrings. So we'll do, wait, this one we just did. You are assigned to put some amount of boxes onto one truck. You are assigned to put some amount of boxes onto one truck. You are given a 2D array box types. You're given a 2D array box types, where box types sub I, given a 2D array box types. You are assigned to put some amount of boxes onto one truck. You're given a 2D array box types, okay? Where box type sub I is equal to number of boxes sub I, common number of units per box. So we have box types, and we have an array of tuples basically, or two columns. We have the number of boxes and the number of units per box. Number of boxes. It's taking a long time to visualize this. Given a 2D array box types. Number of boxes and the number of units per box, okay? Number of boxes, the number of boxes of type I. So each row is a specific type of box. Number of units per box. Number of units per box sub I is the number of units in each box type I. So we'd have row 0 or box type 0. We'd have 3 boxes of type 0, and number of units per box divides the number of units in each box of the type. This is really meta. Is this a recursive problem? You're also given an integer truck size. Oh no, I think this is a dynamic programming problem. You're also given an integer truck size, which is the maximum number of boxes that can be put on the truck. You can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. So truck size is the number of boxes. Turn the maximum total number of units that can be put on the truck. I think I see what they're saying. We have a truck size, which means we have some overarching unit, which is a box, and then one box. Let's say the truck can hold 10 boxes, but we have a bunch of box types, each row being a new type of box. And then we have a number of those boxes, and then a number of how many units we can fit, or a number of units inside those boxes. So if we have 3 boxes of type 0, and each box has a unit of 5, we'd have 15 total units, but it would still be fit within 3 boxes. This is going to be a confusing problem. We can put any boxes. You can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. Return the maximum total number of units that can be put on the truck. Interesting. We have box types, which is 1. We have 3 box types, 1 unit of the first box, 2 of the second, 3 of the third. Truck size is 4, so we can fit 4 boxes. The maximum that we can put on is probably 1 of type 0, which gives us 3 units. We have 3 boxes left. And then we can put 2 of type 2, which would give us 3 times 3 plus 2 times 4, which would give us 7. Then we can put 1 of box 3, which we end up actually using all of the boxes. Now in this example, we have 5 boxes of unit 10, so automatically we can get up to 50, and then we have some other box units remaining. We can probably use 3 9s to give us 27. This problem, it probably isn't as simple. I'm pretty sure this is literally a dynamic programming problem. The box type dot length is up to 1,000. Number of boxes. Oh, number of boxes by number of units per box. And truck size is up 10 to the 6. I'm pretty sure this is a dynamic programming problem. It sounds like a what do they call it? It's like knapsack. No. Yeah, it's like knapsack, except they were maximizing something instead of minimizing something. Oh, DP. Oh, DP. DP indeed. I feel like the intuition behind DP is that it's secretly a graph. But I don't know. I'm pretty sure this is a DP problem. DP. So we're stuck on a new problem now. I feel like one approach, I just realized my environment didn't even load. So we can't even type. I feel like one way to think about this is a greedy approach. Take a greedy approach. What if we took a greedy approach and we just put the boxes with the highest number of units on first? I feel like that sounds like it makes sense until it doesn't make sense. For example, say we had a truck of size 10 and we had a box with a unit of size 5. Now, let's just say we had a couple of boxes. Let's just say we had, how do you do it? FN8, FN5. Yeah, we're just going to use the infinity symbol. Let's just say we had infinite number of boxes for each, and we have one of 5. We have one of infinite of 4, and we have infinite of 2. And I think this is why this is a dynamic programming problem, because this one would be infinite weight or infinite unit, or they call it something like that. But this one would be the opposite. We would have a finite set of resources that we're trying to maximize. It seems in this case, if our truck size is a size 10, actually, let's just do it like this. Oh, no, I got it. I figured it out now. If we had this, right, a truck can only take 2, let's just say it can take 3 boxes. The first box we can put on, right? Let's just, okay, it doesn't work with infinite. Let's just say we only have one of this big box. We could put on 5, right? If we did the greedy method, we would just put on 2 more boxes. Which would give us 13. Actually, I was trying to find a method in which I thought, yeah, maybe this only works with a finite number of boxes. What if there's only one box of 4, and you could do plus 2? From here, you would get 11 instead. I think since we're maximizing the number of boxes, we don't necessarily have a constraint on our units. So I think what I'm worrying about actually may not be a problem. I thought that there could be some scenario in which, let's just say we were maximizing for like maximum unit size, right? Let's just say our maximum unit size is 100. Let's just say we have some box that gives us like 50, another box that gives us 48 or something. It would get us up to a 99 or 98, but let's just say we had another set of boxes or a finite number of set of boxes or whatever, right? But the units were actually in 3s like we have in this third part here. What we would do is just do 50 plus let's just say this was 44. You could do, 3 times 12, which would give you 36. And then again, which would give you 48. Pretty much 3 times 16 would give you 48, and you would end up pretty much here with 98. So it was this thing where, like, if we take the greediest option every time, we end up not being able to maximize number of units. But that would be only if we had, I guess, a unit limit. We don't. We just have a number of boxes. So maybe we could just take a greedy approach. What if we just sorted the array based off the unit size and then kept taking boxes until we couldn't take them anymore? It seems like it would work in all these cases. We could sort it by box, by unit size. We'd take 10 5 times, and then we'd take the remainder. Oh no, then we'd take 9 as much as we can, and then 7. I think in this way, time complexity would be n log n. So what if we did that? Do box types dot sort. We'd have A, B. Actually, we should visualize this. We don't know if this works. You would take all of these, which would give you, I guess we need to figure out why example 2 works. If it works because they took all the front ones, then that makes sense. So we'd have 50. Then we want to take as many 9s as we can. That would be 27. So far that would be I guess we need 2 things. We need boxes and we need units. We start with 50. We took 5 boxes already to get 50. Now we would take 3 boxes to get 27. That would give us 77. Right, then we would take 77 minus 91. 91 minus 77 is 14. 91 minus 77 is 14. So we can take 2 boxes of 4. And you should get 91. There's no other way to do it. So I think we should be good. Let me double check again. 50 plus 41 does give you 91. So if we sort this, we'll sort it by this should actually tell me that it's a tuple. Because it's an array of arrays. So we want to sort it basically in descending order of box type. Return 0, and then we'll check if it was sorted by the method we thought it would be. Or unit, yeah, we wanted to sort it by units. So we did. Okay, so we're gonna have max units equals 0, and that's what we're gonna return. We want to return the maximum total number of units that can be put on the truck. So I think what we want to do is say while truck size. No. What we want to do, because it's possible we might not be able to fill up the truck with all the boxes. So what we want to do is say let I equals 0, and we'll pretty much Yeah, I think I see. We pretty much want to iterate over I equals 0, I is less than box types dot length. We pretty much want to iterate over all box types, and then for each box type, we're going to dawdle, or we're going to hang around and pretty much ask the question, how many of this box type can we fit? So we'll say while truck size is greater than or equal to 0, because we're going to be subtracting to it, and here we can just pull out, we can destructure num boxes and box units out of box type sub I, and we're just gonna say and num boxes is greater than 0. We're going to do max units plus equal 1. I mean max units plus equal box units. And then we'll do truck size minus equal 1, as well as the number of boxes available from this specific should be decreased. And then once num boxes is 0, we'll just stop. We'll pretty much finish the loop, and then or the truck is full, we're just going to keep going. So let's take a look at this one. At the end, we would sort them, right? We would get 5, 10, 3, 9, 4, 7, and 2, 5. We'd put all first the 5 boxes. So we destructure onto box types. The num boxes would be 5, and the box units would be 10. The truck size is equal to 10, which is greater than or equal to 0, and num boxes is greater than 0 because it's 5. Say max units plus box units, truck size minus 1 because we put a box onto the truck. The number of boxes that remain is decreased. Do that 5 times, then we go to 3 9s, put as many 9s as we can. Then we go to 7 to the box types with unit that can hold 7. And I think this should work, or maybe not. I see. So we will take it. It looks like the time complexity is we're going over each box. And for each box, we're going to do num boxes operations. So what would the time complexity here be? It's at least linear time, since we're going over the box types array. It's definitely constant. Oh, no, it's not linear time. It'd be n log n, because we have to sort the box types. But you could make this linear. No, you couldn't make this linear time. So n log n. The question is, does n log n override what's happening here? Worst case scenario, the number of boxes on each unit, the number of boxes for each box type. Could be a lot. Yeah, there's no max size on the truck. It's just number of boxes. So I keep forgetting that. So I think, yeah, I want to say, I feel like this for and while loop does beat out the number. This for and while loop does beat out n log n time, but I can't tell what the time complexity is. It's at max num boxes operations, but that changes depending on the box. So what's the worst case? The worst case would be that each box unit, I guess the worst case would be that the number of boxes is at max 1,000. If it's at max 1,000 and we could have up to 1,000 box types, you have 1,000 times 1,000. 1,000 times 1,000. That's a lot of boxes. My hip hurts, man. We need a better seat. This is a very ghetto setup. It's very ghetto. Max units would be equal to 0. Let num boxes count box units equal box types. All truck size is greater than 0 and box. Okay. It remains unclear. Truck size, we're doing at least linear time operations. And it also seems that the number of boxes could be at max 1,000. So I want to say worst case this is n squared because the number of boxes could be 1,000 and box types.length could also be 1,000. So for every box, we would do n operations. Should be n squared. I feel like this is n squared. Okay, yeah, I think I need to read this because I don't really get it. N squared, where n is the number of elements in array box types. Oh, the number of boxes that you can put in the truck. They're taking the min of the remaining truck size. So let's just say there's 10 boxes left. And box types, if there's only 3 boxes, then we can put all of them in. Ah, that's really clever. And you can just do box count times box types. I mean, box count pretty much times the unit cost. That's really clever. So I think we would be able to get n log n time then. We could just replace this while loop with what they did. You wouldn't have to subtract from here. Truck size, we would subtract truck size, either the min of truck size or the, what is it called? The number of boxes. And the max units, we would just take the math.min of truck size or num boxes times box units. Wow, LeetCode dudes or LeetCode people are nuts, man. That is crazy. The LeetCode people are indeed nuts. Taking the min. We take the min. If the number of boxes remaining is minimum, that's the maximum number of boxes we can put in. There's only 1 box left. If the truck size is smaller, there's only space for 1 box. That's really cool. I don't really, we'll do this one. We have reverse words in a string 3. Given a string S, reverse the order of characters in each word within a sentence while still preserving white space and initial word order. So we're pretty much reversing the individual words. All the words in S are separated by a single space. S does not contain any leading or trailing spaces. I think you could just write a regular reversal algorithm. And you could do this in linear time or 2n. One iteration through to get all the spaces where there, one iteration through to get all the locations where there's a space. And then another iteration to pretty much reverse all the strings in those locations. So from here, I think you could spread the array into a string, or spread the string into an array. You can have another variable called space idx's. And from here, we can just do for let I equals 0, I is less than r dot length. We'll do space idx's if r sub I equals a space, then we'll just do space idx's dot push I. And then we can define another function called reverse, which will take an array of strings, actually reverse it in place. Then we'll take a start and an end. And we'll just turn this from left. I mean, these are already by value, so I don't think we have to re-copy them, but the question to ask is if end IDX will be exclusive or inclusive. Seeing as we're going to find the spaces here, we probably just want it to be inclusive. So we'll just say end IDX is inclusive. And then we'll say while start IDX is less than end IDX. We'll say const temp is equal to r sub start IDX, and since we're keeping a temporary location for start, we're going to replace temp sub start IDX with temp sub end IDX. Oops. And then r sub end IDX gets the value of temp. And then we'll do start IDX plus equal 1, end IDX minus equal 1. Should reverse them in place. And we should be able to return r.join. And then we should just have to, I think we can start space IDXs with a 0 in it, since our string is guaranteed not to have any leading zeros, but we're going to want to be able to reverse the first string. And then at the end, we're going to want to do space IDXs dot push pretty much r dot length minus 1 as the last index, because we want to be able to reverse the last character. Then from here, I think we can just do I equals 0. So we'll have 0 to here, and then from here to here. So we'll have, actually we probably, now we have an issue. The way the array currently worked was that you could just reverse pretty much anything between pretty much every 2 indices. So you have a space here and a space here. You could reverse that, and you'd have a space here and a space here. So you could reverse that. But if we add these zeros, oh yeah, it still works. It still works. I think you just need to, so for each index, you'll reverse between the current index and the previous. Problem being, we don't want to push space IDX push I, we want to push I minus 1. So you don't want the space of this, we don't want the index of the space, we want the index of the character. Actually, no, we do want the index of the space because we want to be able to get the other character as well. So yeah, I think we should exclude what we did originally and just work with the spaces instead. And this way, I think it'd make a little bit more sense. Because right now the algorithm could just work based on the space indices in themselves, because they're going to be subtracted and or added. So we'll say I equals 0, I is less than, wait, we don't want to delete space index, we just want to delete the value it started with. I is less than space IDX is dot length. Minus 1, that's just because we're always going to be working one index ahead or basically the current index and the next index need to exist. So we'll reverse these two, and then this one and this one. But we want to ignore this last space. So we'll pretty much just call reverse R with space ID. Space IDX is sub I. Don't have the space index. We're going to want to add one to it, and then we're going to have space IDX is sub I plus 1, and then space IDX is sub I plus 1 minus 1. Because we'll have this space here, we want to add 1 to it to start at T, and in this space we can subtract 1 from it to start at E, reverse it, then go to the next one and do the same thing. And the thing we just have to remember to do is to make sure to reverse starting from the 0 index to space IDX is sub 0 minus 1, passing in R, and then we want to do space IDX's subspace IDX's dot length minus 1 to get the last space, right, which will be right here. And then pretty much just go up to R dot length minus 1. Okay, it does not work. Okay, so our output is basically correct, but we're missing a space. It's probably because we want to do plus 1 here. I see. We didn't consider. Did not consider. I would say that was definitely quick. I mean, we did not consider strings with no spaces. So what's happening here is we don't find any space indexes, and so we end up trying to reverse these final ones. We end up reversing it. Actually, not at all. This is undefined. So we could just say if space indexes dot length is greater than 0, we'll run these 2 bits of code. Otherwise, we'll just run regular reverse starting from 0. Going up to R dot length minus 1. So it looks like this would be linear time. We do one iteration through to count the spaces, another iteration through to swap the strings. This is also linear time because each reverse does visit every string. And then we'd reverse the final 2 words, finishing the linear time. So it looks like this would be linear time with linear space. Linear space because we're spreading the string into an array. But probably because JavaScript doesn't have mutable strings. I feel like if it had mutable strings, then it would be constant space. Yeah, I feel like they end up doing the same thing we do, except they have C++ has mutable strings. So, you know, we'll chalk that one up there. And let me erase the solution. And we'll call it there.